Welcome to the AI and GIS Frontier podcast. Let's get into today's topic.
Today we are diving into Open Source GeoAI Frameworks. A maturing ecosystem of free tools is democratizing geospatial AI, and this is leveling the playing field for organizations of all sizes.
What are the key tools GIS professionals should know about?
The core stack has 3 layers. At the foundation is TorchGeo, a PyTorch library that provides geospatial datasets, samplers, transforms, and pre-trained models. It gained independence from Microsoft in August 2025 and is now community-governed with open monthly meetings. On top of that is TerraTorch, released by IBM, which is a toolkit for fine-tuning geospatial foundation models. You can fine-tune a model without writing any code, just by editing a configuration file. And then there is the GeoAI Python package, which provides a high-level interface integrating PyTorch, transformers, and geospatial libraries for end-to-end workflows.
Let us make this concrete. How would a forester use TorchGeo?
Say you need to build a tree species classification model from Sentinel-2 imagery. With TorchGeo, you define your study area, and it handles downloading the satellite data, creating training chips, applying appropriate transforms, and loading everything into a format ready for model training. It has built-in support for dozens of remote sensing datasets and pre-trained model weights. The part that used to take a GIS analyst weeks of pre-processing in ArcGIS or QGIS, downloading tiles, mosaicing, clipping to study area, extracting training patches, TorchGeo does in a few lines of Python. A forest analyst with basic Python skills can go from raw satellite data to a trained model in a day.
And TerraTorch takes it further?
TerraTorch is specifically designed for fine-tuning foundation models. It includes automated hyperparameter optimization, benchmarking support, and a modular model factory. For a practical example, say you want to use NASA's Prithvi foundation model to detect forest disturbance in your management area. With TerraTorch, you load the pre-trained Prithvi weights, point it at your training data, edit a YAML configuration file to set your parameters, and run the fine-tuning. No deep learning expertise required. The toolkit handles the complexity of adapting a billion-parameter model to your specific use case. For organizations that want the power of foundation models but do not have a machine learning team, TerraTorch is the on-ramp.
There are some newer tools emerging too.
GeoDeep launched in 2025 from UAV4GEO, focused on lightweight object detection and semantic segmentation with minimal dependencies. It only requires ONX runtime and Rasterio, which makes it easy to deploy in environments where you cannot install heavy frameworks. For forestry field operations where you might be running inference on a laptop in a remote camp, that lightweight footprint matters. MapColor AI is another interesting one, using large language models to help with map design and cartographic styling. You describe the look you want in natural language, and it generates the color schemes and symbology. It is extending AI assistance beyond analysis into the visual communication of results.
The Open GeoAI community initiative sounds important for the field.
It is. Open GeoAI aims to make geospatial AI collaborative and accessible by integrating Earth observation foundation models with large language models and prompt engineering. They are building shared resources, tutorials, and pre-trained models that any organization can use. For smaller environmental organizations, conservation nonprofits, or government agencies with limited budgets, this community approach means they can access capabilities that were previously only available to well-funded research labs or large corporations. A wildlife agency wanting to use AI for habitat mapping does not need to build everything from scratch anymore.
There is also an open textbook now.
GeoAI with Python was published as a free, open educational resource. It covers the full pipeline from data acquisition through model training to deployment. For GIS professionals who want to learn geospatial AI but find the academic papers intimidating, this textbook is an excellent starting point. It assumes GIS knowledge and teaches the AI side in the context of spatial problems that will feel familiar. FOSS4G 2025 also highlighted the growing maturity of the open source geospatial AI ecosystem, with sessions on digital twins, interoperability, and practical deployment patterns.
What is your recommendation for someone getting started?
Start with the GeoAI with Python textbook to build conceptual understanding. Then install TorchGeo and work through its tutorials using a dataset relevant to your work, whether that is land cover classification, change detection, or object detection. Once you are comfortable with that, try fine-tuning a foundation model using TerraTorch on your own data. The progression from textbook to TorchGeo to TerraTorch gives you a practical learning path that builds on each step. And join the community, the TorchGeo monthly meetings, the Open GeoAI forums, the FOSS S4G community. Geospatial AI is moving so fast that community connections are essential for staying current.
The Open Source GeoAI stack is clearly production-ready and accessible. No excuses left for not getting started.
None at all. The tools are free, the documentation is good, the community is welcoming, and the demand for these skills is surging. This is the best time to start learning geospatial AI.